we're going to take a look at some of the foundations for quadratics. We're going to work with quadratics in the following weeks, but some basic things to review this week. So first objectives are to be able to factor a trinomial and to be able to solve a quadratic by factoring. But before we can even get into those outcomes, we really need to look at what are quadratics. So quadratics are something that we studied in detail in our high school or prerequisite algebra courses. And so I want you to pause and think about what to know about them. So first thing, what do the equations look like? And so we have a generic form of them where we have y equals ax squared plus bx plus c. And the key thing about them is they have a squared exponent. So they could be much simpler than this one, which is that standard or general form. So we might just have y equals 3x squared, and that would be considered a quadratic. So the key thing is that exponent of 2. And this one that I just wrote, y equals 3x squared, would be considered a power function, but they don't have to be, they don't have to be power functions. So we might have y equals 7x squared plus 4x plus 9. And so they can have these additional terms that our power functions don't have. Next question is, what do the graphs look like? So the word that we have for the graphs is parabola. And we use that word because they take on so many different of our other words. So let's take a look. A very generic parabola is this one. This particular graph is concave up. The first half of it, moving from left to right, is decreasing. The second half is increasing. The first half decreases at a decreasing rate. The second half increases at an increasing rate. And so we have just a whole lot of vocab there. And so we simplify all that by naming the shape as parabola. And then we could also have a graph of this nature. And again, it would be called parabola. The parabola is like this U shape. It can be going up or down. And again, this one is concave down, and it has all the other features. So it's increasing at a decreasing rate, then it's decreasing at an increasing rate. And so we don't talk about these graphs with all that vocab. We just say parabola. The shape is this U shape called a parabola. Next is, how many solutions do they have? And that is 2. And the reason why is because the exponent is 2. Let's take a look at that on the graph as well. So if I graph something like this, and I would say, let's have 0 is equal to whatever this parabola is, ax squared plus bx plus c. Where does this equal 0? Well, it crosses the x-axis twice, so it equals 0 here and here. And so it has 2 solutions. And that's going to be the case no matter what number is over here on the left. So if we had 7, we'd put a line across with 7, and it would intersect our graph twice. Or if we had this one up here that was opening downward and we put a line at -3, it would intersect twice. So we would always get 2 solutions. Lastly, we want to think about methods to solve. So one way to solve is to graph them, because we have the graphing calculator, and we just looked at a sketch of the graph and we saw there's 2 intersection points. We can do that on our calculator. A next way to solve is factoring. And this one has a limited place that you can apply it, but it is the one we're going to look at today. So we're just going to check that one off our list by focusing on it today, and then when we get into quadratics, we'll look at some of the other methods. Third one is the quadratic formula. You may have learned a little song to help you remember that. You may have it programmed onto your calculator somewhere, but that is, you would have spent a lot of high school time learning that, and we will get to that, but not today. And then you would have learned completing the square. This one is algebra intensive. We will do a little bit of it. Again, we'll kind of limit the way that we apply it because you do have other options. So if it's really intense algebra, we can opt for something else that is not as intense. And then for very simple ones, we have taken the square root. Because we know square root is the opposite of squared. And so if we have something that is just a power function like this first one, I could divide by 3 on both sides and then take the square root to get x by itself. When we take the square root, we are going to have to use the plus or minus so that we get the two solutions. And again, we'll get into that later in the course.